Exercise 6.3, problem 6 solution. A point O is interior of a rectangle ABCD, is joined to each of the vertices ABCD. Prove that OA square plus OC square equal to OB square plus OD square. So what do they say? There is a point O inside a rectangle, and that point is joined to all the vertices A, B, C and D, and we are asked to show that OA square plus OC square equal to OB square plus OD square. So let's draw a simple diagram. So this is our A, B, C, D. Please be careful, either you'll have to put it in the clockwise or anti-clockwise. Otherwise it will be a little difficult. That way also it can be done, but this is a better way. A, B, C, D. Okay, and then through E, and this is O is a point. So join them. OA, OD, OB and OC. Right, so now they are asking us to show that OA square, that along this diagonal, OA square plus OC square equal to OB square plus OD square. Now through E, through point O, draw a line parallel to the longer side, that is AD and BC. It's a rectangle, right? So these two are parallel and these two are parallel. These two sides are parallel. So now let's draw a line through O parallel to AD or BC, right? So this is the line EF and it touches AB at E and DF at F. Now you see this is a rectangle, right? AEDF is a rectangle because these two are parallel. Similarly, these two sides are parallel and these two are already parallel, right? So they are rectangle. This is another rectangle. EBCF is another rectangle. So what does it mean in a rectangle? This side AE equal to DF and EB equal to FC. That is 1 point. Next you see this is a right triangle. Right, so this is, if it is parallel, it is perpendicular to this side, right? So this is a right triangle. So this is a right triangle. Similarly, this is a right triangle. So this is a right triangle. Similarly, this is a right angle. Now, if it's a right angle, what does it mean? OB square will be equal to OE square plus AB square. Like that, you can find out OA square, OD square, and OC square. Then, with suitable manipulation, we should be able to get the required equation. Okay, so let me work it out for you. So draw EF parallel to DC through O, meeting AB at E and DC at F. Now as I told you, these two are AEFD, that is AEFD is a one rectangle and EBCF is another rectangle. Okay, because this line is parallel to both sides. And these are right triangles, OEB, OEA, okay. Then OFD, then OFC are all right triangles. Now by Pythagoras theorem we get OA square will be OE square plus EA square. Then OB square, okay, next will be equation 2. That is OC square will be equal to OF square plus FC square. Next OB square will be equal to OE square plus EB square. Next OD square will be equal to OF square plus FD square. Now we want to find OA square plus OC square. So add equation 1 and 2. Similarly, add equation 3 and 4 to get the right hand side of this equation. Okay. So when you add OA square plus OC square will be equal to OE square plus OF square plus EA square plus FC square. That's what is written here. Now, next is right hand side of this equation is OB square plus OD square. So OB square plus OD square will be equal to OE square plus OF square plus EB square plus FD square. So now you see both of them have the same OE square and OF square. So both are equal. So this portion is equal. So these two portions, if we can equate it, then the left hand side of these two equations will be equal. Now closely observe this EA square and FC square, EB square and FD square. So now look at EB square. That is EB, right? This is, but you know EB is FC, right? So this is equal to this. Right. Next EA square and FD square. Look at FD square. FD. But FD is EA. Both are opposite sides of this rectangle, right? So you know these two are equal. So which means these two are equal. Am I right? So this equation, this can be written, actually this is, this can be written as OE square plus OF square, and instead of EB square I'll write it as FC square, and instead of FD square I'll write it as EA square. That is equation 6. But now you compare equation 6 with f. The entire right hand side is equal. OE square plus OF square plus EA square plus FC square. Here also we are having OE square plus OF square plus FC square plus EA square. It's just changed order, but it is the same, right? Instead of you have EA square here and you have FC square. So the right hand side of these two equations are equal, which means the left hand side of these two equations must be equal. So OA square plus OC square will be equal to OB square plus OD square, and that is what you are asked to prove. You got it? So basically all we need to draw one line parallel to AD and BC through O and name it as EF, and use the principle of the use right triangle Pythagoras theorem, and opposite sides of this rectangle are equal. Okay, that is AE equal to FD and EB equal to FC. If you use these two principles together, you will be able to solve this problem. Okay, so please pause the video and try to work this problem on your own and check your working against our solution. Thanks for watching this video.